one of our triple hitters up next. Ken Roy led a seminar yesterday on terraforming. As you heard earlier, he's going to be leading one of the working tracks tonight on dark skies. But he's up now to talk about solar shields or planetary protection from the sun. Ken?
Solar shields. I'm going to be talking about solar shields. The concept really is a geoengineering approach to solar radiation management in an effort to mitigate or even reverse global warming, which is a main driver of climate change. The concept was first proposed by James Early, who usually makes it to these symposia, but he wasn't able to make it this time. He published an article in JBIS in 1989. And since then, a number of other people have published pretty much on the same concept, but they generally call it different things. Roger Angel is he here today? Okay. Anyway, he called it a cloud of small spacecraft. Other people call it solar shields, planetary sunshades. A group I'm affiliated with calls it Dyson dots. And the overall idea is fairly simple. If you want to cool off the Earth, you just put an object between the sun and the Earth to intercept some of the sunlight that otherwise would hit the Earth. And because the overall energy input into the Earth is smaller, the temperature goes down. Well, let's go back here. Usually we talk about placing this at the Sun-Earth L1 point, but because really we're looking at solar sail type craft as our solar shield, we have to deal with radiation pressure, solar radiation pressure, and that forces the optimum point sunward of the classical L1 point. McInnes has looked at that pretty closely, and he's published a paper back in 2015 where he said, if you want to minimize the mass in order to affect a given radiation reduction, you have to go 2.44 million kilometers from Earth. The traditional L1 point is about 1.5 million kilometers from Earth. So this is pretty significantly sunward of the classical point, but that's the optimum point, it looks like at this point. Okay, how much solar shield do we need in order to cool the Earth? And here, let's look at the 1 degree C reduction. We need about 34 million square kilometers of solar shield. And how much mass is that going to be? Notice that there are two numbers here. The 21.2 megaton number is for dark sails, and that has an aerial mass, again, per McInnes, of about 6 grams per square meter. The large number, 127 megatons of solar shield, is for a highly reflective sail, and that's got an aerial mass of 36 or 37 grams per square meter. And to translate that into starships, which seems to be a unit of measure anymore, if you're going to use dark sails, you need 235,000 Starship launches for the dark sail. And if you want to use a highly reflective sail, you're looking at 1.4 million Starship launches. Because we probably will be somewhere between, the actual number might be between those two numbers. And if you want to, use a different temperature reduction, then you can see the other numbers. There's 1.5 C and 2 C. Okay, what does this solar shield look like? We probably aren't going to build a single structure in the hundreds of, or in the millions of square kilometers. We're probably looking at, as Roger Angel pointed out, a fleet of smaller spacecraft, and they'll probably look something like this. This is a picture of the Solar Cruiser mission that NASA is going to launch in about 3 years. And it's going to demonstrate a number of capabilities that we have to have for our solar shield elements to work. The Solar Cruiser is going to have portions of its sail demonstrate variable reflectivity. In other words, it can adjust its reflectivity on command. That's a very important function for what we need. It's going to have pitch, yaw, roll, momentum control systems on board. Of course, it's a solar sail, so it's propelled by sunlight. It's going to have some onboard navigation capability. It's going to demonstrate the station keeping ability near the Sun-Earth L1 point. And again, for what we want, that's perfect. It's going to have embedded photovoltaic systems. So the systems on board the sailcraft are going to be completely solar powered. And based on conversations with Les Johnson, he says that the aerial density right now for this mission looks like it's about 22 grams per square meter, which is right in the middle of what we were talking about for the Optimum Point before. Okay, here's the IPCC projections from their latest report. You know, I'm not going to talk about the IPCC. Let's just take their graph here at face value. We have the temperature today, you know, that's that circle. And they have run a number of different scenarios based on greenhouse gas emissions. The very top number is very high rates of emission, and then you have high emissions, and then you have moderate emissions. And then the two lines in the shaded area are low emissions and very low emissions. And what the report recommends is that we greatly reduce real soon our greenhouse gas emissions, and that we invest very heavily in carbon capture technology so that we can keep the global temperature below that 2 degrees C rise, which they feel is necessary. Okay, if we were able to affect a 1 degree cooling with our solar shield that we talked about earlier, and we were able to get this in place by 2060, we can take a scenario where we have very high greenhouse gas emissions and lower the global temperature of the Earth to a number that the IPCC would like us to have, even in the face of very high emissions. And I believe the very high emissions line is where we are currently. And if we do the 1.5 degree C cooling, and we have that in place by 2070, so we have a little bit of time to get it in place, again, we can take the very high emission scenario and bring the global temperature down to what they would consider to be acceptable numbers. And of course, here's the 2 degree cooling. Again, we talked about that. And if we have that in place by 2080, we can maintain the global temperature within limits that the IPCC wants us to have. And, you know, playing with lines and a little bit of arithmetic, if we start in 2035 and we have solar sail element launches, you know, 200 to 1,200 Starship launches per week, and continue that to 2080, we can maintain an acceptable global temperature per the IPCC for as long as we need. But one of the objections that has come up to this approach is, yeah, but if you have that many launches, isn't that going to affect the environment in itself? And I couldn't find anything on SpaceX Starship, but I did find something on Skylon. This is, again, a reusable launch vehicle that the British are looking at. It burns hydrogen. And this environmental report assumed that you had 100,000 flights per year. It burns hydrogen, so it deposits a lot of water vapor in the stratosphere. Water vapor is a very powerful greenhouse gas, but you know, doing a little bit of numbers, it looks like the cooling effect from the solar shield is far greater than the warming effect from the additional water. Well, one thing that surprised me, and here I'd like a little bit of help, is nitrous oxide production apparently results from hypersonic reentry of vehicles like this, and certainly like Starship, because the shock wave apparently has enough energy to break up molecules, and when they reform, sometimes you get nitrous oxides. Nitrous oxides are very damaging to the ozone layer, and this report said that with the Skylon vehicle at 100,000 launches per year, you're going to erode the ozone layer by 0.5% per year. Now, can we reduce this phenomena? You know, again, I'd like help on that number or that question. This is, you know, kind of new to me, and I haven't really had a chance to dig into it too far. But at the very least, this would argue that rather than direct launch from Earth, we need to start thinking about building the infrastructure in space to utilize lunar or asteroidal resources to fabricate the solar shield elements and then launch them from there. I think that would get the launch rate down significantly. If you go to an environmentalist website, one of the designs you can get on your t-shirt is this, Plan A because there is no Plan B. And sometimes it's called Planet B. But what I want to argue is that we have a viable Plan B in the offing with solar shields. And that's because of a number of factors. Launch vehicle costs are really, really coming down. Musk is promising he can get launch costs with Starship down to $20 a kilogram. That seems a little bit aggressive, but it's far, far, far better than what we have now. We talked about the fact that most of the technology we need for these solar shield elements are going to be demonstrated in about 3 years with the solar cruiser launch. So we're not too far from having all the technology we need to begin to develop and build and launch solar shield elements. And motivation, there's a lot of motivated people who want to deal with climate change and global warming. So if we could tap into that, I think we have a viable Plan B. So Plan B, the solar shield concept, we can protect our biosphere even in the face of very high greenhouse gas emissions rates for really as long as we want, as long as we continue to launch these things. It buys us time to achieve a carbon-free economy. The IPCC report is really talking about radical reductions in the next decade, and very high, or what they also want is very high investing in carbon capture technology. So rather than trying to do all this in a decade, this will buy us time, a century or two, to more leisurely transition over to a carbon-free economy if that's what we would choose to do. And incidentally, I think it also gives us the key to the solar system because we will have demonstrated the ability to build space-based infrastructures. Not sure what that is. Okay. And finally, I just want to say that one group that's actually looking into this potential or this option is the Planetary Sunshade Foundation. There's their web address, and you can check on them to see what they're up to. And they're also looking for volunteers. If anybody can contribute, feel free. So really, that's what I got. If we have time for questions, okay.
Great, thank you, Ken. First question, would it be less massive to put shields in Earth orbit, taking advantage of them being closer to the surface of the Earth and blocking more light?
The answer is no, because if you have it in Earth orbit, most of the time it's not between the Earth and the sun. So you've essentially got to build a belt that circles the Earth. And looking at the numbers, no, that doesn't work. Now, launch-wise, you might be able to gain from there, but the reading I've done indicates no.
Okay, thank you. Has anyone considered a sort of reverse Fresnel diffraction system to disperse?
Oh yeah, that's in the literature. The problem there is the precision you have to put into the lens is such that it makes it difficult, not impossible, but difficult. And with the solar sail, you're intercepting photons, you're reflecting photons, and with the lens, you're just diffracting photons. So the complexity doesn't seem to really buy you anything.
Great, thank you. This seems like an interesting repurposing question. Do you have any thoughts on using the solar protector to capture energy and use it for beamed energy?
Oh yeah. We've looked at that very extensively. For time-wise, we weren't able to get into it. But yeah, with photovoltaics built into the sail, and given the area that we're talking about, and assume 10% efficiency, and just 10% of the sail is devoted to collecting energy, turns out you've got like 30 terawatts to play with. So yes, that is certainly a possibility, and that opens up a whole new realm of excitement. Yes.
Great, thank you. Would there be an advantage to building the shields on the moon?
I think so. Because of the launch numbers that we saw there, it's It's possible, but it's probably not credible, especially with the nitrous oxide problem. And again, if anyone can help me out with that, how do we reduce the production of nitrous oxides with hypersonic reentry, or is there a way? So if we just simply, we can greatly reduce the numbers of launches if we think in terms of building infrastructure, on or around the moon to use lunar resources. So I think that's probably the best way to go.
Great, thank you. And I guess if we have time, I'd like to actually ask my own question. Would placing a sun shield at the L1 Lagrange point affect current or future spacecraft at that position?
Well, again, we aren't going to be at the current Lagrange point 1. We're going to be significantly sunward of it. And I don't see that there's anyone else who would be there for any particular reason. It might be a good spot to look for solar storms, and we can certainly incorporate that technology in the solar shield, so that if it sees a coronal mass ejection coming towards Earth, it kind of warns us.
Well, we are out of questions, and thank you very much. We got through quite a bit.
Okay,
Ken.
thank you.